Okay, here what we have is your basic trigonometry problems. And make sure you know the ratios. And I would definitely recommend you at least do 5 correct in a row. Maybe just do 30 of them real quick. I mean, you know, they really don't take any time at all, but let's make sure you know them well. So here we go. It says, what's the tangent of angle BAC? So the vertex is given as the middle letter. That's A, right? So you're talking about from angle A. It's another way we can name this angle is we just call it angle A. So remember tan. Tan is, took our apples, right? TOA. So tan is opposite over adjacent. So we know the opposite side is this one. That's 24, right? The adjacent is the one. See, they both, the angles always have, right? Whichever angle we're looking at always has one leg that's in hypotenuse and the other leg that, you know, 2 sides to every angle, right? And one of the sides is going to be the hypotenuse, and the other side is going to be a leg in the triangle, right? So the leg is the adjacent leg, and then there's a side of the triangle which is not any part of that angle, and that's the opposite side. So from A here, we're doing the opposite over the adjacent, so our answer is 24 over 7. Now I just do like a couple more real quick. What is the tangent of BAC? So again, the key is to start by saying what angle am I at? I'm at angle A, and which function do I need? Tangent is opposite over adjacent. So angle A, opposite is 5 over adjacent is 12. So 5 over 12. Okay, here we are at angle B, right? We're at angle B. So B is right here, and we want the cosine. So cosine is, came around here, right? So adjacent over hypotenuse, so 7 over 25. The sine of BAC, so we're at angle A again, right? Because it's the middle letter there, so that's our vertex is A. Sine is sum, old hog, sum opposite over hypotenuse, so it's 8 over 10. And then cosine of ABC, so we're over here at B, and we want the cosine which is adjacent over hypotenuse, so 8 over 10 again. And that's how those are done. Real simple. Okay, let's go to the next level of trigonometry. This is trigonometry 1. So now it's going to ask me, okay, it's saying you have AC, let's see, it's asking me for the cosine of angle BAC. So again, this is angle A, and they want to have the cosine of angle A. And cosine is adjacent over hypotenuse. So that's 4 over 41, now, or root 41. Now the problem is, we don't like to have root 41 in the denominator. Notice it says, rationalize the denominator. So if you had an answer that was 4 over root 41, the way that we rationalize is we multiply top and bottom by the root of 41, so that the bottom becomes 41. And so our answer is 4 root 41 over 41. Okay? And, you know, if you need to practice with that, just let me know. I can help you practice, but this is basically the same kind of problem here. What is the cosine of ABC? So I'm over here at B. Cosine is adjacent over hypotenuse, so 7 over root 130. But we want to get rid of the root 130 in the denominator, so we multiply by root 130. Moves it to the numerator. We have 7 root 130 over 130. Here we have the tangent of BAC. So it's from angle A, then it's opposite over adjacent. So 10 over 3. None of the above. There it is, 10 over 3. The next one. What is the sine of ABC? Sine of ABC is, let's see, from angle B. Sine is opposite over adjacent, so it's 9 over 9 root 2. So 9 root 2. So what I want to do is I want to get rid of that root 2. So I'm going to multiply top and bottom by root 2. Okay? And actually, the 9 over the 9 root 2, the 9's cancel. So it's really 1 over root 2. So when I multiply the denominator by root 2, and then the top by root 2 becomes root 2 over just 2. Trust me, or do a little work with the calculator, or have me help you with those if you need to, the rationalizing denominators. Those are a little tricky for some kids, but you can use the CAS calculators, and they will rationalize it for you, okay? Let's see. Let's see the tangent of angle ABC. So we're at angle B over here. Tangent's opposite over adjacent. So that's 8 over 4. So 8 divided by 4 is 2. Not listed here. There it is, 2. So that's how those are done. Not much trickier, just included some irrational numbers in here. So now here we have, given that this side is 20, what is the length of this hypotenuse? So we're given this information all about angle B. Sine ABC, B is over here. Cosine of B, cosine of angle B and tangent of angle B. So we're sitting here at B, and we know the opposite side, and we want to find the hypotenuse. The hypotenuse. So we know the opposite, and we need to find the hypotenuse. We're going to use the ratio that is opposite over hypotenuse, and that's sine. So sine is equal to 5 over 32. So we write ourselves an equivalent ratio. We say 5 over 13 is equal to 20 over x. And you can just think, how does 5 become 20 times 4? So 13 times 4 is 52. So it's an equivalent ratio problem. I'm not going to work through how to do equivalent ratios right now. If you need help with those, you let me know. Just showing you that they're not that tricky, really, what we're going to be doing here. Again, A, B, C. So here is B. And now you just think, now that I'm in B, which are the sides that we know and want to know? We know the opposite. We want to know the adjacent. Which function is opposite and adjacent? Tangent. Tangent is took our apples, opposite over adjacent. So we have 24 over 7 equals 48 over x. Well, 28 becomes 48 times 2, so 7 becomes x. 7 times 2 will be 14. Okay, and then here we go, another one. They're looking for the hypotenuse. We know the opposite. We're talking about B here, so opposite over hypotenuse. That is, again, sine opposite over hypotenuse. And this is the same problem we had before, because I recognize that we use this sign. 5 over 13 equals 20 over x. So, and that answer was, what did we say it was? 52. All right, we're again using B, angle B, right? We know we need to know the opposite. We know the hypotenuse. So the opposite hypotenuse is the sine function, some old hog, right? Opposite of hypotenuse. So we get 24 over 25 is equal to x over 50. Well, I would double 25 to get to 50, so I better double the 24 and get to 48. Okay, I'm over here at B again. We are given, we do not know the opposite, we do know the adjacent, so it's x over 10 equals, opposite over adjacent is tangent, so it's 12 over 5 equals x over 10. So the denominator was doubled from 5 to 10, then the numerator must be doubled too, from 12 to 24. That's how those are done. Okay, let's take a look at the last of this little set. So there's 4 of these. You should be able to go through them pretty quickly once you've learned well your trig functions. Okay, so here, let's see what we have. We know, this is just like those other ones. We know one side, we have a missing side. Just make sure you always check to make sure when they're doing these problems which angle they're talking about. And that middle letter is the vertex that we're talking about. So we're talking about angle B. What we know is that the hypotenuse is root 61. We don't know the adjacent side. So which function is adjacent hypotenuse? That's cosine, came around here. So it's adjacent over hypotenuse. So the adjacent would be x over root 61 equals 6 root 61 over 61. Okay, so really, the trick here is just knowing how am I going to write my equivalent ratios. Then solve that equivalent ratio. So in my case, I know I'm looking for adjacent over hypotenuse, x over root 61, adjacent over hypotenuse, that would be the cosine function. So x over root 61 equals 6 root 61 over 61. And then When I cross multiply and solve for x, I get 6. So again, not really harder, other than that the numbers are getting a little more difficult. So which function are we going to use here? We're at angle B. The functions given are for B, okay? So we need to know the opposite. We know the hypotenuse. Which function is that? Get it? Sine, opposite over hypotenuse. Some old hog, right? So it's opposite over hypotenuse. So x over root 74 equals 5 root 74 over 74. Okay? And I'm going to pause and let you figure that out. And then if you did your math correctly, you'd get 5. If you set up your ratio and did your math correctly, you got 5. Okay, here we go. You know, actually doing these right now, I'm not going to do any more of them because it's just me sitting and working through them on a calculator. I don't do these by hand anymore. I can, but I'm not going to. And you shouldn't need to sit and watch me just work through these problems. You can do them yourself. Write the ratio. Last ratio, I'll tell you what this ratio is because we can see it. We're talking angle B. This is opposite over adjacent, so that's tangent. Okay, go ahead and solve this problem on your own, or go ahead and get started on your exercises.